today's session, we will learn the concept behind waveguide tees. As we know, the waveguide tees are manufactured to the highest mechanical and electrical standards. They are just coated inside with either silver or gold for the purpose of resistivity. However, the waveguide sections can take up various shapes like rectangular, circular, square, elliptical, reentrant or rigid type. Let us learn the definition of T section. It is just the intersection of waveguides to form the English alphabet T. They are also generally characterized by third order matrix with 9 elements in which 6 are independent. Now we will go into the types of waveguide T's: E-plane T, H-plane T and the magic T. E-plane T is otherwise called as a voltage T or the series T. H-plane T is otherwise called as a current T or the shunt T. And the magic T is combination of E and HT, all called as hybrid T. It is a 4-port device. Today's class we will confine to E-plane T exactly. E-plane T is a 3-port device. So a rectangular slot. Now imagine this is a rectangular waveguide. A rectangular waveguide is cut along the broader dimension. Another waveguide is intruded. Then it is forming an E-plane T. The transmission of the electromagnetic wave can be either through the main arm or through the side arm. Now in this diagram, this is the general representation, same block diagram. This is port 1, port 2 and port 3. Imagine the power is fed from port 3. It is equally split into 1 and 2 as shown in this diagram, but in the phase reversal. How to write it mathematically? In general, in S matrix, in your transmission lines in RF you would have learnt Sij defines power flow from jth port to ith port only. So I am defining from port 3 to 1 it is going, from port 3 to 2 it is going equally, but in phase reversal. So mathematically minus of S13 is equal to S23. Now we will have the analysis of what is E-plane T. It is a 3-port device. As it is a 3-port device, I am writing a 3x3 matrix. This is step 1. Next we'll move on to definition of E-plane T with port 3 perfectly matched. By definition of property of S matrix, if it is a perfectly matched device, then the diagonal element is equal to 0. So all diagonal elements will be equal to 0 if it is a perfectly matched device. But it is defined clearly, it is matched only with respect to port 3. So S33 is equal to 0. So I am making S33 equal to 0 in the next step. Next, by definition of E-plane T, already we have defined S23 equal to minus S13. Now we will go into the symmetry property. By definition of a symmetry property, Sij is equal to S of Ji. So I can write S12 equal to S21, S31 equal to S13. So in this you replace S31 by 13 and S23, 32 by 23, and then also substitute this condition S23 equal to minus of S13. So both the steps I have included, symmetry property and E-plane in this modification. Next we'll go on to the unitary property. By definition of unitary property, S of S conjugate is equal to identity matrix. So yes, I have written conjugate of the same matrix. Your transpose or the identity matrix is equal to for a 3-port device. So this is also the property of S matrix. Summation SNI conjugate is equal to 1. Same way SNI conjugate is equal to 0. Note the difference. SNI conjugate. This is SNK conjugate equal to 0. I am going to substitute this. Now let me take R1 C1. So S11 conjugate plus S12 conjugate plus S13 conjugate equal to 1 plus 0 plus 0. So that's what is written over here as R1 C1 equal to S11 of 11 conjugate is S11 square itself mathematically. So plus S12 square plus S13 square equal to 1. Similarly, I write R2 C2 and R3 C3. 3 set of equations we get using unitary property. Now let me go to the zeroth property. Using the zeroth property in R3 C1, I have R3 as S13 minus of S13. Same way C1. So S13 of S11 conjugate minus S13 of S12 conjugate plus 0 equal to 0 by zeroth property. So I am writing the equation of R3C1. Now to identify the values, let me do the simplification of further steps. By definition of R1C1 equal to R2C2. Now equate these two equations. After cancelling out the like terms, I have the equation to be S11 equal to S12. One step I have obtained. Now, you choose this R3C3. 2S13 square is equal to 1. That's what I've written. 2S13 square is equal to 1. So S13 square becomes equal to half, or S13 becomes equal to 1 by root 2. Next step we have identified. Now we'll go back to the definition of R3C1. This equation is rewritten as S13, you take out common, S11 conjugate of S12 conjugate equal to 0. But in the previous step I have identified S13 equal to 1 by root 2. So S13 cannot be equal to 0. So automatically S11 conjugate minus S12 conjugate becomes equal to 0. Which means that S11 conjugate is equal to S12 conjugate, or mathematically S11 equal to S12, which is also equal to S22 by definition. In the previous step we have seen. So now I go back to first equation R1C1. So S11 square plus S12 square plus S13 square equal to 1. I have proved that S12 equal to S11. So substitute S12 equal to S11, and S13 is 1 by root 2. So 1 by root 2 whole square is half. So 2S11 square becomes equal to half. So S11 square becomes equal to 1 by 4, and S11 becomes equal to half. As we know that S11 equal to S22 equal to S12, all these four elements are half. S13 and minus S13 have replaced by this component. This is the S matrix of the E-plane T. Thank you.